we have considered an uniform electric field and where an electric dipole is kept, and your length of electric dipole we have considered as twice L. Now you see, say this is your at B point positive charge Q and at A point negative charge Q, and this is the direction of your electric field. So as you know, in an electric field, positive charge force experienced in the direction of electric field. That's why here the force will be in the direction of electric field, and at the negative charge, wherever negative charge is there, force will be in the opposite direction of electric field. Now see, the line of action of both the forces are different. That's why it will create a torque. That means rotational motion will be there, and torque is responsible for the rotational motion. But net force is zero, you see. If you calculate the net force on the electric dipole, they are equal in magnitude. That will be your QE minus QE equal to 0. As amount of charge is Q here at the point B, and your electric field intensity what? E. Electric field intensity E means that is force per unit charge is C. So force on Q coulomb charge is Q times C. And in this case also Q times C, but opposite in direction. That's why net force in the electric dipole, that will be 0. Now, but as the line of action of the forces, this force acts along this line and this force acts along this line. So line of action different, it will create a torque. Then torque, as in class 11 also we got the definition, it is either force, means any one of the force you can consider. So force into length of the or perpendicular distance between the line of action. And in this case, perpendicular distance is what? BC. Now, say the electric dipole makes an angle theta in the with the electric field intensity. This angle is theta. Then from here, what you will get? Sin theta equal to, from this right triangle, BC over twice L. This is the hypotenuse, which is nothing but the length of the dipole. And from here, what you will get? BC equals to twice L sin of theta. Now, torque will be equal to F into twice L sin theta. This is equal to, now F is what? Force is any one of the force, either force you can consider. So any one of the force you consider, force is what? Q times C in this direction, and here also force is Q coulomb charge, electric field intensity E, so Q times C in this direction. So let us write QE into twice L sin of theta. Now simple arrangement is there. Again you know, dipole moment is what? Dipole moment is your either charge multiplied by length of dipole. And for our convenience, we consider the length of dipole as multiple of 2. You can say twice A or twice L. Here we have considered twice L. That's why if I give Q into twice L together and E sin theta in this side, then what you will get? Q into twice L is dipole moment P and E sin of theta. So now you see, torque we have obtained as, just magnitude we have considered, PE sin theta. And this in vector form, as torque is a vector quantity, in vector form you can write, that is your dipole moment, P cross product of electric field. This is your expression for torque whenever an electric dipole is kept in an uniform electric field. And how to find a direction? It is simple, cross product of vectors. Say here is a vector A vector, another vector is B, angle between them theta. If you find out A cross B, vector product or cross product of two vectors, then direction will be what? Direction will be, you just imagine your it is anti-clockwise, some screw is kept here, and if you rotate it in this direction, because you are taking A cross B, if you rotate like this way, it will come outwards. So direction will be perpendicular to the plane of the board but outward. If you take B cross A, then tight the screw, then it will be again perpendicular to the plane of these two vectors but inward. So that way we can get the direction of torque. Just simple, that is nothing but cross product of two vectors. That way you can remember it. So simple, I think easily you can do it. But in your board exams, if deduction is given, you have to write in a systematic way. Thank you.